Okay, so let's see a trick to get rid of the noise, the high frequency noise that we sometimes get on simulation. This also works for hair simulation and cloth simulation and whatever vellum simulation that you're doing. If you use low numbers of steps because you're in a hurry, sometimes you get this kind of results. So here I just have a sphere. I did a mountain, which is a deformer, and I put an offset the frame. So we have this kind of really ugly noise. We wouldn't have that in a simulation. If you see a simulation like that, it's wrong. But sometimes in some places you have this kind of behavior. So the thing that you need to do is just create a delta mesh and make it as far as you want just to get rid of the noise. So something like that, it almost has no noise. So that's great. Even more, okay. And then what we do is what it's called a delta, which is the difference between this geometry and this geometry. That is really easy to do. I'm just doing, well, this one, this guy doesn't, we don't need this guy for anything really, but well, comment this guy. So I'm subtracting this information from this information. So it's a subtraction of the position of every point in every frame. So what I have is something like that. And this is just the noise because it's the difference between this one that doesn't have noise and this one that have noise. So if I subtract one of the other, so we get just the noise. This is the noise happening. Okay, so now I just created a null to send it to chops. Chops are like the channel operators, the one for animation. And we just create a channel right here with the chop that I created here. This is just to create a chop network, and you have that. And the channel is just channel, yes, yeah. Okay, so inside this chop network, we have a geometry, and we loaded our null that set chops, and we added a filter. This filter is what is going to be a Gaussian filter for the noise. So right now we can see we already have a lot less noise than we had here. It's much smoother, but we can make it even better just by pumping this up as much as we want. You can see now it's not a high frequency noise, it's low frequency noise, and we can just pump up a little bit that also, and now it's almost unmoving. We can just play with that. Okay, once we have the noise removed, we add it again, just like that. We add it again. We can just do that if you want, just grabbing the P from the input one and just adding it. We can delete this guy. Okay, and adding it again. So now we have almost no noise. Maybe we'll have some kind of changes you can see, but these won't be really noticeable in a simulation. This was like a crazy noise. We shouldn't have that, but even then we can just get this really high, something stupid like that. Maybe it's going to be a little slow to process the filter, but once we have, you can see that it's almost not, well, it's much better, worse now. So maybe we shouldn't do that much of a noise removing. Anyway, this is the way to get rid of the noise, and you can do the same thing a couple of times. That's the nice thing about Houdini, that we can do something like that and get these, just like that. Here we can get our geometry, which is the chops one, which is already done. So now we can just copy and paste this guy, and I guess that, yeah, the delta mesh comes here, and this is what I want up, and we have even less noise. In fact, this one, I guess, can be much slower, just like that, maybe 5, 1, and we will have a smooth transition. We still have some kind of noise, but this would be the deformation that you already have in the simulation. So this is the way to remove the noise on a jiggly and noisy simulation. That's all.